Hello, I'm speaking to you from sunny Ireland, Dublin. Hope everybody's doing well. We're at Dublin HQ for Alldus. I'd like to welcome you all to our health podcast on AI. Hope everyone's doing really well today. My name is Mark Kelly. I'm the Chief Customer Officer at Alldus. I'm also the founder of AI Ireland, which is a not-for-profit initiative set to help build clusters of AI in Ireland. And we also have the AI Awards, which showcases the innovations across startup companies, large enterprises, AI for good, and look to do innovation in AI and how we can actually move it forward. Today, I'm going to give you a little bit of an overview about Alldus, and then I'm going to tell you a little bit more about what you've got installed with the AI healthcare meetup today. So Alldus is a recruitment company specializing in AI and data science, and we cover Berlin, New York, and Dublin. So move forward in AI. So we came together on the basis that we're passionate about moving forward AI, and we look to be very community driven in our approach to doing that. So in all this, we're ambitious, we're listeners, we're learners, we've got drive, we're unified, and we're specialists. We've got offices in Brooklyn, HQ is in Smithfield, Dublin, where we cover Europe, and Brooklyn, we cover most of the US. So before COVID, we were running several meetups across Berlin, Dublin, and soon to be in New York. And we have different initiatives where we've got speakers across, talk about NLP, computer vision across a variety of different industries. It wouldn't be uncommon to have 100 to 150 people come to our meetup. To give you a little bit of a breakdown of some of the people that would be involved and come to the events, majority would be data scientists within data engineering, also software development, machine learning engineers, and then that's mirrored in Berlin as well. We've had over 100 speakers speak, with over 7,000 attendees and 40 total events. Now that we've gone virtual, that's increased substantially. So our podcast series, so if you, in case you haven't heard of them, one is AI in Action, and the second is AI Mentors. In AI in Action, what we look to do is solve business problems by applying machine learning. So people come on the show and share how they're using machine learning to solve business problems. Combine that with AI Mentors. And AI Mentors, the podcast series is focused on how you build out and manage a data science or an AI team. So it's challenging enough to maybe recruit a world of AI, but then suddenly you need to manage them for research. That doesn't necessarily work particularly well with return on investment, because the very nature of some of the projects that are in data science, there's a lot of research element to it. So people can fall down rabbit holes, and trying to allocate KPIs to make sure you generate return on investment is going to ensure that people that are backing and investing in the company will be more happy to continue to do so. So our guests share about their experience getting into the world of data science, which is very, very diverse, and also their learns along the way, how they've applied different models to actually generating certain problems being solved, and then later they talk about the advice that offer their younger self as well. We have over 100 episodes now, and these can be found on iTunes, Stitcher, or Alldus.com. We're really, really proud to be one of the fastest growing AI recruitment companies in the world. And we're also now one of the most trusted recruitment companies in the world with over 200 5-star Google reviews. One of the things that mostly come up is our integrity, our ability to produce extremely good results for both candidate and clients, and also our professionalism. But as we're community driven, we want to make sure that we actually add a lot of value. So we feel like people can come onto our website and generate a lot of the really relevant content to help them on their journey, either to get a role or to network or to find out more about the business. So the challenges facing AI in healthcare. Well, firstly, when you think of AI, there's so much potential. We were looking at quotes to show today, and there was a lot, but the quote that came to mind was this: the day healthcare can fully embrace AI is the day we have a revolution in terms of cutting costs and improving care. You've probably seen so many post-its about the applications of this and how it can actually go to the next stage. Some of these things can be overhyped. An awful lot of this is image detection and looking at how we can actually spot cancer in certain x-rays, for example, and working with different doctors. But there are some challenges before we realize the benefits, the full benefits of healthcare and AI being applied together. Ultimately, people do not trust this. So one of the challenges that you have is that if you're to get a weather update and it says 90% chance that it's not going to rain, Well, chances are you won't bring your umbrella. But if somebody said gave you a diagnosis, you're going to get a different opinion, and it's something that you either have to get right with a lot of certainty, and people want to also have humans in the loop. So when you're actually looking at some reports, or maybe AI is giving some feedback on something, you want to have a human in the loop that actually give proper diagnosis when people are actually going to feel a lot better about that situation as well. So the first thing is going to be on trust. Also, there's technology limitations of AI. So when it comes to algorithms, a one-size-fits-all approach does not work. So solving new tasks requires innovative designs and creations, and a computer vision being a good example of this is to understand medical images as well as NLP for text within frames. Companies like Page are operating in this space, mining massive healthcare data sets to build a new machine learning systems for computational pathology. We recently did a podcast on Page, and if you go to alldus.com, you'll be able to find out more information about that. So then we look at actually better regulations. So with certain AI technologies set to appearing in hospitals sooner than we think, therefore machine learning and radiology, we must look at the challenges this would face in the areas of compliance and regulation. One solution is this for policymakers is to get ahead and begin to set standards for these practices, and AI standards beginning at small medical professionals to national level healthcare systems. And then finally, you've got finding the data and the privacy. So uncovering where the data is not as obvious as it may seem. It is a lot more complicated than other fields, for example, such as retail. Healthcare is a bit more of a dark market where it comes to readily available data sets. Bring them, hide forever, Sana. Data protection, once it's procured, is also a challenge. One simple but not so simple solution is to tightly regulate and encrypt a connection between the data itself and the details of who it belongs to. So we have a dedicated session in our podcast focusing on recent healthcare guests. They're actually applying machine learning to actually add real value when it comes to healthcare. Please feel free to reach out and listen to them, and you can find them on Stitcher, iTunes, as I said before, alldus.com/podcast. So if you're looking into getting a new role, a new opportunity, getting into the field of data science, or just trying to find out just general good interview tips and advice, on alldus.com on career advice, we have over 50 blog posts that give you advice on how to get into the world of data science, how to nail that interview, how to write the perfect CV, how to give you advice on a cover letter, how to actually look into try to get into specific areas of machine learning, loads of different guest posts as well too. So on alldus.com/career advice, you'll be able to receive over 50 different posts where you'll be able to look at this different content and be able to go onto your journey there. There's also jobs, as you'd expect with a recruitment company. We've got a variety of jobs there as well across Europe and Ireland and also in the US. Here's a sample of some of the roles that we're actually looking to recruit for. Please feel free to reach out at mark@alldus.com if you want to find out more. We can reach out also with the team here, or check out info@alldus.com, and you'll be able to find out more information about getting a role in the world of data science, software development, or machine learning as well. And that is over for myself there. I'm absolutely delighted to be introducing our first guest today, and he is Mathew Devine. And Mathew is the interim head of data science at BIX Digital Lab, Boehringer, and he creates value through innovation with one clear goal: to improve the lives of patients. So he's going to be talking about unstructured text integration and text mining. So Mathew also goes by the name of Data Dude, which he's going to be able to share a bit of a story about that as well. Kind of putting you on the spot, Mathew. I'm not sure if you're expecting to share that story. But there's also, he comes from California originally. He's lived in Texas, and he's lived in Berlin as well. And he's going to share a little bit about his journey too. And we're absolutely delighted to have him on the meetup. And then later on, we're going to welcome Tassilo Waldraff, CTO at Cephalometric, and he's going to speak about landmark detection on X-rays as well. So over to yourself, Mathew.
Well, Mark, thank you very much for the kind introduction and for putting me on the spots to tell you why it says on my LinkedIn profile, Dr. Data Dude. So I wore this shirt today because I love the dude from the Big Lebowski, the dude abides, and I try to abide too. And that goes for applying cutting-edge machine learning algorithms and technology to some of the most difficult problems in healthcare today. So what I'm going to do is I'm going to present to the audience today a little bit about BIX, the Digital Innovation Laboratory for Boehringer Ingelheim, one of the top 20 pharmaceutical companies in the world, and tell a little bit about what we do in order to create top-notch digital products which have the sole aim of improving the life of both people and animals. So without further ado, I will go to the next slide if my computer will allow me to do that. So what is BIX? Like I said, it's the Digital Laboratory of Boehringer Ingelheim. We want to create digital innovative products to save and improve lives both for people and animals, and we drive the digital transformation of Boehringer Ingelheim, so bringing in different digital business models to the company. So we're located in Ingelheim am Rhein. This is in Germany, sort of southwest of Frankfurt by about an hour, but we work globally and have and work in the global markets. So BIX in numbers, it was founded in 2017 with about 20 million euros in seed funding. They hired about 51 people within that year, created one product, had in the MVP, 2 in pilot, and 7 in rollout. So you understand that terminology, I'll explain it to you in a moment. We have partnerships with multiple incubators and startups, and interesting fun fact, there are 19 languages spoken in BIX, so it's a very diverse working atmosphere. So BIX is a group of top-notch digital talent. That's right. It's not just data scientists working there. It's UX designers, data scientists, scrum masters, front-end developers, back-end developers, and we have an entire team devoted to ideation and scouting. And when you work at BIX, then you work in a product team and you're developing a digital product from beginning to end, and you do this in an interdisciplinary team. And it's a great journey. The products that we build, we stay on them for about a year before handing them over to the business side, and we start from ground zero. So the UX designers, this is the empathetic person on the team. At least that's how I like to describe them, as not always the quality that you get from your software engineers or from your data scientists, sort of out of the box. But they look into the research problems and identify and engage the potential users, the people who have that problem that we want to solve. And they give some designs and prototypes out, and with the helps of data scientists and software developers, we are able to put together a product that we work on iteratively in order to basically work on a hypothesis that we keep from the beginning to the end of the product. And then we're helped along the way with our Scrum Masters. So we run in a Scrum Agile manner. And if you're not familiar with Scrum or a Scrum Master, I had working with a Scrum Master, Leo, for about 2 years together on 2 different projects. And he broke it down to me like this. He said, you know, Scrum Master in the best possible way, a Scrum Master is a life coach. The Scrum Master should enable the team to reach to its highest potential. In the worst case scenario, it's just a project manager. So I enjoyed working with Leo, and he did a lot to enable us to see our full potential as a team as I worked with him. So we have 2 main services. We do the development, service development, product development, and then we also do external innovation and partnering as well for the business unit that are interested in looking for solutions to some of their difficult problems, or to pair up to the new digital products that we're building. So when we start off on a journey, we usually build up a team of interdisciplinary group of folks. So in green, you got everyone from the UX designer to the software developers and data scientists. These are like your digital natives. Then you have in yellow here in the middle, you got your product owner. This person comes to the business, and this is your entrepreneur type. This person needs to bring in the vision to the team and drive the direction of where to go, and then interact with different subject matter experts and lead the team through networking and also in discovery of what it is to build this product that we're building on. So we have a pipeline, and we start in the ideation phase where someone from the business will come over and says, I got this idea. I think we need to do this because we got this problem. And so the ideation team, they work with them, they scout the market to see if there's something out there to solve the problem, if this is a unique problem or it requires a unique digital product. Then it'll go through about a month of iteration and ideation, grooming the idea. And once we get support from the business unit, it rolls into MVP, which we call the minimum viable product. This lasts anywhere from 2 to 4 months. And the question is, will this work? And what hypothesis are we proving? And then basically trying to prove the hypothesis. Like for one of our digital products, it was called Pet Pro. It's really caught on since the coronavirus because it's an application which allows veterinarians and pet owners to get together through telemedicine, basically. And so as you can imagine, with the restrictions placed upon us all through Corona, it became a necessity or much easier to get into contact with your veterinarian through telecommunication. And so this is one of the products we developed, and throughout the journey of the MVP is like, is this really going to solve the issue and make the life easier for both veterinarians and for pet owners? And yes, it was. And so basically, let's test it out with a pilot group of folks, and then they try to roll up, ramp it up. And once we've shown that it's working with a pilot group, we push it on outside of BIX to the business unit and to the IT inside of BI, where it is then developed further, and that's how it works. So this is just kind of another view of the pipeline that you see here. And so altogether in the last 2 years, we've have this funnel where we've taken 500 ideas or more from the business side. We've filtered them down. We put in together 14 MVPs, and from these 14 MVPs, we've been able to get rid of 6 of those ideas and say, no, they're just no good. They're not gonna hack it here. And then we had 8 pilots, and then even in the pilot, we had 1 fall off. And so we've had 7 rollouts of various digital products in the last 2 years of BIX. So yeah, just to name a few, you see we had the Pet Pro, which is for connecting veterinarians to pet parents. We have Farmera, which is the aim is for pig producers to produce healthier pigs, basically. Brass is one for pharmacovigilance, an internal product that helps Boehringer Ingelheim pay better attention to how drugs are being used on the open market once they're out of the controlled environment of clinical trials. NTC Studio, for example, had the goal of helping early stage researchers fish through large amounts of unstructured data in a very smart way and come up with new therapeutic concepts to drive through our innovation pipeline at Boehringer Ingelheim. Smart was one of the products that we had where we were able to increase the production of some of our drugs that we make for ourselves, but we also make drugs for a lot of other pharmaceutical companies. And through using machine learning, AI, we were able to increase the production efficiency. This was a really great product there. And then B2P2 is also a product that I worked on and stands for biomarker-based patient population. And it's was a catalog for clinical trial data that we had internally, which allowed researchers to browse through different clinical trials that we had in a very much easier way than they've ever done it before. It opened up that space way beyond traditional data analysts to more of the layperson who didn't have such a huge technical background, and they were able to come to the insights of their own. So without much ado, I would like to continue on from giving you the overview of BIX, and I'd like to give you an example of one of the first products that I worked on at BIX. It was called NTC Studio. And basically, the idea of NTC Studio was to gain high quality and innovative therapeutic concepts which would have greater chances of being first-in-class breakthrough drugs for the Boehringer Ingelheim pipeline. And so the value proposition was basically, let's create a platform for our scientists, people, right, to foster the collaboration and support knowledge sharing across the entire organization, yeah, and cut down the silos. And so we do this with the help of data and decisions. All right, and so we built an app to do that. So what I'm going to do is I'm going to kind of go through. The problem statement is that, you know, you've got this gal over here on the left side. She's got a great idea. She's got her own databases. She's got her own thoughts and everything. And then there's a wall, right? And then there's another guy, and he's in his lab, and basically they have the same great idea, or they have complementary great ideas, you know, but they're using different data sources or the same data sources, and there's no exchange of their data and their ideas, and they could even be on the same building just down the hallway from each other, right? So we got fragmented data. No one knows what their colleagues are doing, and you need one place for data exploration and collection. So we had to do a data integration project here. So I just show off the development stack. You can see, we used a lot of different technologies to get there. So on the data science side of things, you know, I used Python at BIX. We had to go with PySpark because we had big data that we had to do the wrangling and mungering on. We used a company called SciBytes. They have a tool called Termite. It's a really great entity recognition software. This was pivotal to the project, and basically linking the different documents in the beginning. And we also had to use Apache Airflow for you know, creating our data pipelines. Of course, you know, you got your Bitbucket, so that's what we use. It's a Git repository. We had a PostgreSQL. Everything we do, it's in Docker containers, and like I said, we use OpenShift, which is our virtual private cloud, where we have, you know, Dockers being pushed through Kubernetes, and then the front end folks were using Node.js and React.js. And basically, I was using Gensim topic modeling, and also getting into some neural networks using Gensim, or not, Gensim. That's what it was. Okay, so as a data scientist, you know, we had this huge ingestion problems with all kinds of mixed data types. It was a mess, let me tell you. You know, PowerPoint, XML, JSONs, PDFs, Excel, Word. And we created a data pipeline, so a lot of data engineering going into this. We had to use Spark for it, and basically we pushed everything through our entity recognition so that we could basically link all the documents. And then once we had linked the documents, it was very important. We used, at that time, it was about 2 years ago, we used Word2Vec in order to model the data and find out similarities between the different unstructured text. Yeah, so that was the workflow, and we put this onto Apache Airflow. Here's sort of an example of the named entity recognition. So one of the data sets we were working with was abstracts. And basically you can see the text of an abstract is in black, and then everything that the named entity recognition picks up is in blue. And so this really makes your life helpful, easy, because, you know, stuff like AF, it's picked up because it actually means something. PAF here in this, patients who develop prospective AF, which is arterial fibrillation, and then it all gets sort of put together. This was a really big help for us. And then even you can look in here, like 60 years is a time, and then greater than, this is also something that we were able to pick up, this expression, and use it. Diseases were very important to be able to know that COPD means chronic obstructive pulmonary disease, for example. Yeah, and so then we use the word embeddings with the word2vec. Here's just a nice little example how you can see that each one of these entities that we had, we mark them, and we allowed the feed-forward neural network to embed these into vectors. And then using the vectors, we were able to make analogies between like diseases and targets for drugs of a certain disease, or drugs and drug targets, and so on and so forth. And it worked very similar to, like, you can say Spain, the capital of Spain is Madrid, and so then the capital of Italy is, question mark, and then the algorithm, given the right corpus of text, would be able to spit out Rome. And the same thing if you have, for a particular disease, this is the particular target that we're looking at inside of a cell. So now I'm in a different disease, so what kind of targets would we be looking at there? And then we could look through the huge, massive abstracts. I mean, there were like 25 million abstracts alone that we ingested, plus other internal documentation with descriptions of this. So it was a great journey. Yeah, and then we use the word mover distance basically in order to work on these vectors. And the really thing nice about word mover distance was you could then take entire sentences. And one of the examples here that I use, Obama speaks to the media in Illinois. And then you have document 2, the president greets the press in Chicago. Well, at the time, Obama was the president of the United States of America. And so if you look at these two sentences, basically they're saying the same thing. They're talking about the same event, probably, if it's in the media, but they don't share any of the same words, basically, outside of the and in. Yeah, and it was with this technology that we could make some comparisons like this. So the researchers who used this platform, they were quite happy to have this type of ability. They don't have this at all. It goes beyond what the usual tools they had in front of them. So that's it. That's BIX in a nutshell. That's one of the projects that we did in sort of what do you call it, data integration, and how we used an example of neural networks, so natural language processing, in order to make the life easier of basic researchers who are trying to make a better world for people with disease. So that's it. If you're interested, we're hiring developers, data scientists, scrum masters, and UX designers. We're at bix-digital.com, and this is our manifesto.
Data dude, that was brilliant. Thank you very much.
Thank you, Mark.
You hit it out of the park there, Mathew. So we're going to save some questions for afterwards. So please make sure that you can just share some comments, likes, to send over any points that you want to get Mathew and Tassilo to speak about in the future. So thank you very much again, Mathew. I'd like to introduce our second speaker, Tassilo Waldraff, CTO of Cephalometric, and the title is Landmark Detection on X-rays. And Tassilo will tell us about their AI product that automates the identification of relevant diagnostic points in X-rays and reduces the analysis time at consistent quality from 15 minutes to mere seconds, thereby allowing dentists to focus more on the diagnostics and the treating plan. So this is really exciting. Tassilo, very welcome to the show, Meetup today. I look forward to hearing from you, so I'm going to let you crack on.
Then who is Cephalometric? Cephalometric is founded by me and my co-founder Jaroslav Blaha. We worked before in a large enterprise company since 2015. We worked across 80 countries, so we have a lot of experience working with large distributed systems. And around 2016, 2017, we thought about making our own thing with this new technology, deep learning. At that time, it was still not that new anymore, but we still thought we can do a lot with it. and then we finally left the company and founded Cephalometric. Besides me and my founder, we have a great team behind us. We hired some young developers who give us a lot of support in building our services. As well, we have great network to universities where a lot of doctors work with us to bring artificial intelligence into the healthcare section. Our mission is pretty simple. We would like to assist dentists in their daily routine to make their life easier. Dentists typically have a lot of stress in their daily work, where they work on many tasks in parallel, mostly small tasks which need to execute as fast as possible. So we would like to make them more efficient to increase the patient care. We would like to make the efforts and the operating costs smaller, and of course we want to increase the quality. And in the dentist field, there is actually a lot to do. I have some numbers on my screen. So only in Germany alone, we have roughly 33 million images in dental, which needs to be analyzed, and worldwide it's 1.4 billion. So there is a lot to analyze for an AI. The problem in this field can be distributed mainly into 4 sections. There is an increasing demand of X-ray images, but the amount of doctors produced by the university is not increasing as fast. So we will have to solve the problem by using artificial intelligence, or we have to produce more doctors. And I think solving the problem with artificial intelligence is obvious the right way to go. Also, problems the dentists or the doctors in general have is their life is pretty stressful. So they have to deal, for example, with a lot of working hours, with difficult patients, with emergency, with risk of making mistakes. And by all that stuff, they have to make sure that they handle the quality management, that they do quality assurance. And with all that, we can help out with artificial intelligence. And when it comes down then to the human complexity, every person is very different. And solving image-based analysis problems with conservative tools which are provided by computer visions are not possible, or were not possible in the past. Now with deep learning, we are able to solve those problems. Some unique characteristics about us is, to our best knowledge, we are the first and only company worldwide which has actually a certified dental service in the market. So generating AI services in healthcare is probably hard, but it's doable. But on top of that, you also have to certify that to provide it or to distribute it in the European market, which is actually quite hard. Our strategy of collecting the data, which is later on needed for the training, is pretty conservative. We follow the strategy that we do not use any data which is provided by data sets from the internet. In our opinion, if you throw in junk data into an AI, you will get junk data out. So what we had to do, or what our strategy is, we collect the data from our partners, and then we re-annotate them in a peer-reviewed manner. All the services that we have are on a secured cloud platform, so they are reachable simply by REST services, which makes it pretty easy to integrate with other partners in the healthcare field. Everything we do is baked by a large community. As I already said, we have a lot of doctors and universities behind us where we're working with. And from them, we also got a large amount of dental images which we can use to build our services. Here are some of our products which are in development at the moment. The first image on the left side is called OPG. Probably everybody has seen such an image before. And there's a lot to detect on such images. So first of all, you can find artifacts which are circled by this orange circle in the image. So some artifacts are lighter, some artifacts are more darker. And those artifacts are typically not what is the doctor is looking for when he is analyzing such an image. When he's analyzing such an image, he looks more for the teeth. So such tools to point him to areas where he should have a second look at is pretty important. The images here with the orange circles, I guess it's not too hard to see that there are artifacts, but there are some which are very hidden, and an artificial intelligence can find such artifacts. Furthermore, we can segment teeth on such OPG images, or we can analyze the kind of implants the patient has in his mouth. So not only that there is an implant, also who is the manufacturer and what type of implant it is. And there are hundreds of different implants. On the right side, we have a typical image which is called a bike wing. And there we do something which sounds pretty obvious in dentistry. We do a caries detection. But caries is not only always something which you have to drill out. Sometimes you can also, let's say, just heal the caries without doing much. And the decision when you have to fill or to drill the caries is pretty hard to do as a dentist. Basically, they don't learn that at a university. In the university, they learn if you see caries, you drill it out. But with new techniques and liquids, you can just heal the caries without any drilling. And we have a caries detection AI in development, which can exactly classify caries for the decision, do you have to drill or to fill the caries? We have many more projects in our pipeline, and it would take probably too much time to go into all of them. But there are some which I like to explain because we use them later on for the landmark detection. And this is the very first one, which is called ModalityNet. ModalityNet was the very first project we made in our company. It was the kickoff project to show that the technology works in general. And what we did is we just classified dental images to its type. So we have bite wings, dental films, OPGs, and cephalometric analysis. And the AI is pretty good in classifying such images. Other products that we have is, for example, age determination, which could be pretty interesting. For example, for the medicamentation of the patient. And of course, this technology is not only related to the dental section. We can also do things like analyzing ECG or to do, for example, facial recognition. Before I go into the actual explanation of how to do the landmark detection, I'd like to show the concept of our basic platform. When we start a project in the dental section, it always happens in the same manner. First, we need to collect the data, and we collect the data from hospitals, from private practices, and from universities. When we get the data from them, they are unstructured, and before they go into our database, we anonymize the data so that there is no information about patients or anything. So we just get the raw images. Then furthermore, we developed a labeling platform where we can schedule campaigns where doctors can peer-reviewed label our data or annotate it. So for example, for the landmark detection, we had 15 doctors annotating our data, and some images are annotated up to 28 times just to make sure that the data is absolutely correct, because in our opinion, this is the basement of every AI, is the correctness of the data. Once the data is labeled, we have something which is in a state where we can run it through our AI. And as I already said, the AI is pretty generic, so we can basically reuse most of our models if the data is correctly annotated. So why do the doctors work with us at all? It's pretty simple. They are excited about publishing everything what they did with us. So once the project is done, they get all the numbers and statistics from us so that they can write their papers. So here's one of our, here's the first here's the first production project which actually went into production certified. It's a web application where you can throw in an image which is called cephalometric analysis. It's a X-ray image of the human skull. And what the doctor has to do in the past was he has to identify up to 44 points on the image manually. This is a task which they tried to solve with computer vision in the past, but they were not able to because the human skull is just too complicated to solve it with traditional computer vision techniques. This is a process which takes, I would say, between 5 and 15 minutes to execute. And in the very beginning, it was a pen and paper task. Now doctors use computer and mouse to identify the points. And with our new service, the points are just found by the AI. Based on those points, there are some routines to calculate angles and distances, but this is an already solved problem. So we just had to apply the same mathematics to those points to get a calculation out of it, which you can see here on the right side. And as you can see, there are some issues with this patient. They are marked with red when a certain threshold is too high. Next, I would like to show you a little video which explains the pen and paper method, just that you get a better idea what the problem is. And this is a method which is executed quite commonly. So computers are not everywhere in dental. Many people still do it with pen and paper. And even if this is a short video, the total execution of the pen and paper method takes pretty long. And next, I would like to show how we solve the problem with AI. And here you can see you just drop in the video and the AI directly detects the points. It doesn't matter what kind of orientation the image has. The AI just figures it out, rotates the image to the correct position, and draws in the points and does the calculation of the values. So, and now's the interesting part, what happens if you throw in a wrong image. Also, the AI just detects it's not a cephalometric image, so it gives a little hint, but it still renders the points down, but obviously they are pretty strange. A little bit about the data. As I said, we have this platform where the doctors can peer-reviewed label our data, and when we started the project, we got around about 3,000 images where the doctors had to set 44 landmarks. Before the labeling campaign started, we did some rounds with the doctors to retrain them that we make sure they are all on the that they are aligned. Even if they learned it in the university to set those points, there still needed some training so that they exactly set the points in the same way. Originally, I said there were 15 dentists. I have in my slide that were only 14. Also, with creating the data, we defined a golden standard. Those are images which were analyzed by all the doctors. Sometimes they were analyzed twice by each doctor. And the peer review of the images were made by the senior doctors as well as later on by the AI. So once the doctors were done and the AI was trained the first time, we run the AI through the whole data set again. And we reviewed all the points which has the biggest differences to the doctors. Here are some results of the precision of the AI. The AI dots are in yellow and the expert dots are in red. And as you can see, the results are pretty much the same. On some dots, they are exactly the same. And sometimes you have to look twice to see the yellow dot. The network itself is pretty big. In our first version, we had 200 plus million neurons. In a newer version, we are a little bit below 100, but it still needs a lot of neurons to compute such images. Here are some different different flavors of cephalometric images. On the left side, you can see images from different devices, and as you can see, they look pretty different, and sometimes they are also flipped from left to right, or the images can have gradients. Some of those images are noisy, so they are very different. And since we only had 3,000 images, and typically you need more data to train an artificial intelligence, we tried to generate our own images with AI. And this is what you see on the right side. This is a work from one of our students where he trained an AI which produces cephalometric images, including the labels we needed for that. This project is promising, but we figured out a solution without using this technique. This is finally how we augmented our images to increase the data pool. One big problem that we had is all our images came from the same data source and from the same device. And this is the image on the left side. All the images look pretty much like this image. And when you remember the images before, they look very different. So we had to come up with augmentation methods to enhance or to increase the data set. And what we did for that is probably pretty common. We put salt and pepper on the images. We worked with gradients, so there are white gradients coming from left or from the inner of the image, and we did a rotation or transformation on the images. And then last, we also adapted the gamma values. A little bit more about the landmarks. The landmarks which the doctors had to set are not just finding one landmarks. In many cases, landmarks have relations. For example, if you see the landmarks or the landmark of the tip of the nose, this is a landmark which you can just set. But then the landmark which is called POG, is related to that landmark. So it is connected to the chin, but it depends on where the tip of the nose is to set it at the correct point of the chin. So you can't set the POG landmark without knowing where the nose landmark is. Some of the landmarks are not set by the doctors at all. They are constructed after you define some landmarks. So for example, the landmark GO is constructed by other landmarks. And some landmarks have conditions. For example, the PPOCP landmark, which is the last point of the tooth. This landmarks becomes another landmark if the last upper or the last lower tooth in the mouth is missing. Here's the chain of the networks we use to calculate finally the landmarks. When we have an image, first what we do, we need to check if the image is a cephalometric image, and we need to check if it's in the right position. So what we do before, in the first step, we transform this image into a square, and we adapt a little bit the gamma curve so that the colors are more recognizable for the AI. This image can be pretty small, and then the AI rotates the image in the correct position, and it understands if it is a cephalometric image or not. And the second part then is we do a normalization on the image. We find or we detect 3 points to then to triangulate the image into a different position so that all so that the skull is always in the same position. So what we do is in normalization step, we are looking for the tip of the nose. We find the point of the chin, and also this little point here, which is close to the ear. And then we rotate and transform the image so that the tip of the nose, the chin, and the point of which is close to the ear, is always on the same position on each image. And once we have done that, we do an initialization step where an AI finds all the 44 points on a single image. And what we do next is we cut the image into patches and run one AI for each point, for each image, to increase the quality of the positioning. So some details about the different nets. The first net, which needs to understand if the image is in the correct position and if it is a cephalometric image, is done by a modality net, which is based on something on the net which we did in the very beginning of our company. So we took our existing modality net, which can classify between different types of images, and we enhanced it to give us the information about the rotation, or also if the image needs to be discarded because it's not a cephalometric image. For that, we used 50,000 images. This was not so hard to label because you just had to sort those images. This were done by one of our doctors. And it turned out that once the artificial intelligence was trained, it had some images which were always incorrect labeled by the AI. So we gave it back to the doctor to check those, and it turned out that the doctor sorted them incorrectly. So he resorted those images, and then we trained the AI again, and we got to 100% correct image classification on our validation data of 3,000 images. So this task was pretty easy to solve, and as I noted down here, we just used a basic convolution reload network to do that. So this is a task which everybody can do. It gets a little more complicated when you go into the landmark detection then. So to find the landmarks as good as possible, it was necessary that we normalize the image beforehand. So sometimes you get an image where you not only have the interested region, sometimes you get an image where you have the whole skull on the image. So first you have to normalize the image so that it's better consumable by the AI. And as I already explained, therefore we calculated 3 points on the skull. There was no need to make them super precise. We just have to find the region which is roughly okay, so we can cut out the part which is actually interesting for finding landmarks. Then in the next step, we calculated all the landmarks. Therefore, we tried many different kind of networks, also known networks which you can download. But the best solution that we found was a convolutional reload combination of normal convolutions and later local convolutions, followed by some dense layers. Some of our images didn't have a complete set of landmark sets, so we also had to apply a process where we can drop out missing labels or missing landmarks. The resolution of those images can be quite small. In that case, we used images with 128 to 228 pixels. And the coordinate system which we used for the landmarks were from -1 to +1, whereby the field of view goes only from -0.5 to +0.5. And in case of point landmarks outside of the image, the AI can still make a guess where that point might be. For example, if the tip of the nose is outside of the image, the AI can still give a coordinate where it thinks it might be. And then the final piece of the landmark detection, and this is actually the most important one, this is the patch net. The patch net can be pretty small, so the network is smaller than the initialization net because it only has to find one landmark instead of 44. The images can be smaller because the region of interest is not that large. We only used images with 64 pixels, and we did the whole process in a recursive manner. So once we feed in the patches, we use the results of the patches and use them as a second iteration to get better results. Also pretty important on those patches is the augmentation process. So when you add noise or gradients or gamma correction, you can't apply the parameters, the same parameters to different patches. So it really depends on the patch. So when you have a patch, you need to find out what parameters for the augmentation you have to set. Otherwise, your results won't be that good. And here's a pretty interesting image. Here you can see how the AI compares to human. We have those circles which are from green to red. Those are the standard deviations. So green is the first, yellow is the second, and red is the third standard deviation. And I also visualized the polygon which is surrounding the dots set by the doctors, and then finally the tiny blue dots is the mark of the AI. And as you can see, the AI is most of the time within the polygon of what the doctors have found. How did we calculate it then later on the metrics? It is pretty important that when you calculate your final point, that you do not take the results from the different doctors and take the mean. It's pretty important to take the median instead, because outliers won't be affecting the results. Second to the comparison of the landmarks, you can also compare the final analysis of such an analysis. So the landmarks are just points, they don't have a real result. The result is, of course, the analysis, which shows angles and distances and ratios. Finally, here are some numbers. I converted the results from the AI, which is, as I explained before, is in a space from -1 to +1. And I took the ruler, which is a little visible here on the image on the upper right side, and you can take that ruler points to convert the image points into millimeters. And there we found that the average error of the AI is round about a little bigger than a millimeter, which is better than the average error of a normal doctor who has 1.1. I also compared the best and the worst cases, and as you can see, the better the doctors label the data, as better the AI gets. So if the AI is worse, it always happens that the doctors are not that good in setting that point, and it's vice versa. Here's my final slide. I draw down my technology stack, and I avoided to put down all the surrounding technologies, how we provide the software to our end users. I just noted down what we took to generate the AI, and it is pretty simple. You really only need Keras with TensorFlow and OpenCV to do such a project, to write an AI module. Yeah, and that's it.
Thank you very much. That was fantastic. Really appreciate that, Tassilo. I've got so many different questions. I feel like I need to go and brush my teeth, though. I'm not sure if anyone's actually ever said that to you before, that after you see a presentation yourself, they start to get conscious of their teeth.
Sorry?
I'm not sure if people ever said anything about their teeth after they watch a presentation with you. Maybe not. Can you hear me okay?
I had a little noise. Sorry.
Okay.
Okay, but now I can hear you too. Sorry.
Okay, perfect. So you mentioned about how dentists and doctors feel very stressed, and it's a profession that a lot of people actually are choosing not to go into anymore because of the stresses and dealing with the public patients who could be very difficult in some cases. And AI is a really good solution in that. It's you kind of went through it within different steps to the problem and how you solve the problem. Did you engage with a lot of different diverse stakeholders to get different perspectives on how you would go about solving that problem, or was it a little bit more straightforward in terms of your thoughts on how to do it?
Well, when we decided to do that project, we basically talked to our doctors, and their problem is they work a lot in parallel. And if you do have to do tiny tasks, even if they only take some minutes, if you have to do them in parallel, it gets pretty stressful. And if you can solve those tasks, other tasks won't be that stressful. So if you have more time, a complicated patient won't stress you that much because you have the time to handle him. And so you can lower down the stressful days if you solve those tiny pieces in the overall process. And that happens a lot. So if you take your X-ray image, it doesn't matter which one it is, it always costs you some minutes. And when you handle a patient, those are the minutes which you are missing to give you your freedom back. So it's typical as a dentist that you probably have 2, 3, or 4 patients in parallel, and on every patient you are on a different step, and then you don't want to mess with your software to do any kind of analysis. You just want to have that done to spend your time at the patient.
Yes. And before you were speaking and before Mathew was speaking, I was talking about some of the challenges within AI applied to healthcare, and I talked about trust, limitations, regulations, finding privacy. Has there been much pushback in terms of trust and obviously having the dentist in the loop or doctors in the loop? Could we maybe remove those people in the loop in some cases?
In my opinion, we cannot, at least not at the moment. I think the doctor should always have the last word in such a process. So every module in AI which we develop is something which just makes the life easier for the doctor, but he still has to somehow accept the result from the AI. I think it will be possible in the future to replace probably some parts of what the doctor does, but by now I think it's not. And an important point is also the quality assurance in that part. So once the doctor has reviewed one of those X-ray images, how can we make sure that when he doesn't see something and he will be somehow get in charge for that, then later on he has to make sure that he can give confidence that he looked at it. This is something which you can do with an AI. If you can point him to certain directions, you can you have a quality security that the doctor looked at that part.
So we had a question come in. You mentioned that it's quite difficult to receive certification to use AI in healthcare. Yeah. What advice would you give to other businesses looking to do the same?
Well, that problem is not related only to healthcare. I think it is in general hard to get certification in that area. And the only thing what you can do, in my opinion, if you are not an expert, you need consultants to solve the problem. So we were not able to solve it by ourselves. So we had many different kind of consultants.
If you were to go back and retrace your steps and do it all again, what advice would you offer to your younger self?
Oh, I love what I do, so I probably would do it again. Actually, I wouldn't do anything different. I think what I would do is focusing more on one project and not as on so many at the same time. But I think I would do it the same way in the bigger picture.
Tassilo, thank you very much. I've got some questions from Mathew, but Mathew needed to shoot off. We were talking in the comments there beforehand. And one of the questions I'd asked him is, what trends are you most excited about in AI across industries? And he had said that explainable AI is an interesting trend, since neural networks are at the moment in many cases black boxes. Digital therapeutics are the up-and-coming trend. BI doesn't have any digital therapeutics at the moment, but we're excited to go into the field in the near future. Digital therapeutics are digital technologies that either end up replacing or augmenting traditional therapeutics, which is very exciting. Probably the same question I'd ask yourself. Any other applications of AI across industries that you're paying a lot of attention to that gets you excited?
Well, I'm always excited in projects which generating something. So if it is art or music or faces, whatever it is, if AI starts becoming creative, this is something where I really enjoy to look at.
Yeah, I believe that the painting went to over $580,000 that the GAN did. I was very interested to see who actually received the money of that. Was it the person that was doing the AI? Was it, there's so many different factors of who actually would have got allocated of the cash to see, but also quite interesting with GT3 and some of the new application from OpenAI as well, from that's going to come too. And I think we're done for questions. I'd just like to say thank you very much for your time today, Tassilo, and also for Mathew as well. We will be making this available and sharing it across different platforms too. And if anyone wants to reach out or find out more about yourself, we'll make sure to put them in contact with yourself as well. So thank you very much again, Tassilo, and hope everybody enjoyed that, watching it at home. Take care.
Thanks, and bye-bye.
See you soon. Bye.